Hi, I'm class 11 as of grade 5 from YUMIN Primary School. This lesson is the methods of limit calculating. We're at method 3, which is the conversion of infinity calculation to infinitesimal calculation. Well, do you know why we change from infinity to become infinitesimal? Well, here, I'll tell you why. So infinity, it is not a fixed number, so we cannot straight away sub it in. So we can actually change it into an infinitesimal. When we change it into infinitesimal, remember, infinitesimal approaches to 0. So actually we'll just need to sub it in as 0. And then we can use that subbing. So this actually helps us to find out the answer to this problem. Okay, so right now I'll try out some examples. So we have 2 of these examples. We'll start from the first. So for this first, which is the limit x approaches to negative infinity modulus x times the x. Then you'll minus modulus x squared. Remember, the square is outside that modulus. Then you have to over here modulus. You have the x cubed plus 4x squared minus x to the power of 5 modulus. Then you minus modulus x to the power of 5 minus x cubed modulus. So first, we will need to try to take away that modulus. So when we try to take away that modulus, we must remember. So let me show you for this. If x is smaller than 0, and inside the modulus is actually just this x. Remember, modulus always makes it a positive. Remember, x in this case, which is smaller than 0, is a negative number. So you need a negative, negative, which makes it a positive. And if x is bigger than 0, well, of course, this is still a positive. Okay, so now we know these, we can try. Remember, inside here is a negative. Here, well, negative times negative, because there are 2 of the negative, which is actually positive. But don't forget about this negative. So actually 2 negative, 2 of them. So we'll have to have this negative 2x squared. Then after that, for this, well, x cubed, when you put this in, is actually a negative. Here is a positive. Here, negative, negative, positive. So when you minus an x cubed, actually it doesn't matter, because you need to plus back an x to the power of 5, which is actually way bigger than that. So for this part, we actually don't need to worry about that, as when you plus the x to the power of 5, it doesn't matter, still a positive. So it's actually like this. Then for this part at the back, well, remember, x to the power of 5. When you sub the negative in, it is a negative. And here, negative, negative, positive. When you plus this and minus this, it's a negative. We cannot have that. So we'll need a plus, because it's a negative, negative, positive. Like this. So what we have is a negative 2x squared. What's that down here? These two cancel. These two cancel. So you're actually over a 4x squared. So this is actually just easy simplification, which you can get a negative half easily. So this is actually just for this first question. Then next for this second question, remember for both of these, well, for the first question, I'm sure that we can use calculator to check. Okay, so if you wanted to use calculator to check, right now I'll tell you how. For this, remember this modulus is actually ABS. So you just, because there you don't have this limit, you just type in a number, and that will be as your answer. So you just need modulus, answer, and after that answer. Then you just type all of these in. Okay, so next for the second, which is the limit n approaches to negative infinity. And here, which is our modulus n over square root n squared plus 2n. And you need to plus the square root n squared plus 2n. Then you minus the square root n squared plus 4n. For this, it looks quite complicated. But actually for this, here's still the limit n approaches to negative infinity. Remember, inside here is a negative. You need to make it a positive. So this is actually a negative n. Then you're over this square root. Well, we can actually just make it stay there. But at this part, it's actually something special. We use numerator rationalization. But you might be wondering, where is that numerator? Well, it's actually over 1. Over 1 is actually just this thing. So, for this, you can numerator, denominator times the square root n squared plus 2n plus the square root n squared plus 4n. So like this, it is actually a minus b times a plus b, which is the a squared minus b squared. So this is actually an n squared plus 2n, then you minus that n squared minus a 4n. So for this, well, it is actually just over that square root n squared plus 2n, then you have to plus the square root n squared plus 4n. So right now at this part, we can numerator, denominator, we can divide it by an n. So first is still this limit n approaches to negative infinity. Divide this by n is a negative 1. Then denominator. Well, for this part, which is actually, I'll just tell you that there's actually a negative. An actual negative. Well, it is because for this, for example, if f, this is smaller than 0, then for the x, if you want to put it into that square root, so for example, so this can be just that square root something, right? So this, remember x is smaller than 0, which is a negative number. Here, when you times it together, it's a negative number. So it's actually this thing times the x. But remember, this is a positive. But this is a negative, so that is why we need an extra negative. So same thing, and times the same. And divide. So this is actually divided by n squared, but you have a 1. Then you plus 2n divided by n squared, 2 over n. So then for this part, it is actually a minus 2n. You can just write it as a minus 2, because numerator, denominator, you can also divide it by n. Divide this by n. Remember about that extra negative. So here, n squared 1. Then it's 2n over n squared, 2 over n. So for this, n squared, still the same as a 1. Don't worry about this 4, it's still a 4. Just a 4 over an n. So for this, next you can just sub the n in. Remember, negative infinity, 2 over infinity. Well, obviously there is a 0. Minus 0. Minus 0 doesn't matter. Minus 0 plus 0. 0 zeros. So this negative can cancel. So here's actually a 1. Then let's look at this part. We can have a 1 here. Remember, the negative simplify. A 1 here and a 1 here. Wait, 2 over 2, another 1. Which we actually will have a 2. Well, this looks very weird. But let me just tell you, if you really want to find out whether this is the correct answer, use a calculator to check. So you just don't worry about this n or this x. It's actually just input n as the answer. So this is actually just answer square plus just that part for example. And also remember the modulus is the ABS. Okay, so remember, it must be a negative infinity. So your answer must be a negative number. Don't go and write it as a positive number. Obviously, it will not be right. And also sometimes when your number is too small, like negative, whatever, a negative very big number, because that the calculator, remember, the first example to a power of 5, you need times itself, something, times itself 5 times, which the number gets very big. So the calculator might just show up math error. Okay, so that is the end for this lesson. So if you like our videos, don't forget to subscribe to our channel. So for this, we'll see you in the next lesson. Thank you for your watching.